So, we've defined the parts that work to pressurize your aircraft. Let's hop into the cockpit and see how they all work together from takeoff to landing. The pressurization system display is found on the bottom of the EIS. Here, the pilot can read the differential cabin pressure displayed in both a bar and digital number format, the cabin rate of climb or descent, the cabin altitude displayed in both a bar and digital format, destination elevation or landing field elevation, LFE, and what's termed high field elevation. The destination elevation can either be an automatic or manual input to the CPCS. In order to use the automatic feature, a destination airport must be entered into the flight plan using your Perspective Touch avionics. In this case, the LFE will be displayed in magenta color on the EIS. You may manually set the LFE value by selecting Aircraft Systems and then pressing the Landing Field Elevation icon. A manually entered LFE will display in cyan color on the EIS. If you forget to enter a flight plan and don't manually set the LFE, the elevation will default to the departure airport. High field elevation will be displayed when the LFE is higher than the maximum cabin altitude during cruise. When the aircraft begins a descent to the destination, the cabin altitude will begin to increase at a rate dependent on the aircraft's altitude as well as the LFE. You've learned about the components and indications associated with the pressurization system. Hang in there, as we're about to come full circle by looking at the actual system operation from takeoff to landing. As you advance the thrust lever for takeoff, the pressurization scheduling process begins. The outflow valve begins to close, which causes a small descent in the cabin altitude, preventing the vestibular ear-popping sensation that would normally be felt during climb in an unpressurized aircraft. At a maximum rate of 600 feet per minute, the cabin climbs to the scheduled cabin altitude for cruise. The CPCS maintains the lowest possible cabin altitude by holding a nominal cabin differential slightly above 6.1 psi. This means that if you're climbing to a cruise altitude lower than the maximum of 28,000 feet, your cabin altitude will be lower than the maximum cabin pressure value of 8,000 feet. Again, the CPCS, through the controller and monitor system, takes care of all of this. As the aircraft begins a descent from altitude, the cabin also descends at a maximum rate of 600 feet per minute until reaching approximately 1,500 feet above the LFE, when the outflow valves are opened fully, allowing inside and outside pressure to equalize. Upon receipt of the weight on wheels signal after touchdown, the outflow valves receive another command to open fully, which ensures that the aircraft is not pressurized once it's on the ground. This will allow the cabin door to be opened smoothly and safely without experiencing any sudden pressure change.